one more section in chapter 6, systems of linear equations. All right, so we now know how to graph lines. We can go ahead and look at the 3 cases down below. Let's go ahead and provide some actual names to the different types of solutions we might encounter. So a solution to a system of equations, and the system, just think there's more than one thing going on, so there's more than one equation. So a solution to a system of equations is an ordered pair or pairs that satisfy all of the equations in a system. We're going to look at 3 different scenarios. The first scenario is where the 2 lines intersect. So that is when we have exactly one solution and the system is said to be consistent. So that is this first scenario right there. The solution is going to be where the 2 lines intersect. There is the second scenario where there's no solution, and that is when we would say the system is inconsistent. And that's what we're looking at in this second case. And the third scenario is when there's infinitely many solutions, and that is to say the lines are dependent on each other, or the system is dependent on each other, and that's that third case. The lines are overlapping. Okay. So number 1, we're asked simply determine which of the ordered pairs is a solution to the following systems of equations. So this is very similar to what we did on the last lesson, where we were just saying, okay, is the point a solution? And we just had to plug it into the equation. Same thing here, we just have to plug it into 2 equations. So again, just a little bit more work, but from a computational, or there's a little more work from a computational standpoint, but let's see what we have. We'll do part A right here first. All right, so we're given x is equal to 0 and y is equal to 6. So we have 2 equations. I'll do the first one in like a blue, and I'll do the second one in a green. So we would have 0 plus 2 times 6 is equal to 12. We have to check that. And at the same time, we should also check 2 times 0 minus 6, is that equal to minus 1? So you just have to check 2 different scenarios. And you see 0 plus 12, is that equal to 12? Yes, it is. And let's see, 2 times 0 is 0 minus 6. Is that equal to minus 1? No, it is not. So this was no, this was yes. So the answer to this first question is no. It has to satisfy both in order for it to be a solution. I'm going to put it underneath. So that's how it plays out. Now, let's go ahead and do the next one. So let's sort of put just something to kind of break up the page here. So B is going to be the same thing. You're going to check this time 2, 5. So x is 2 and y is equal to 5. So we'll end up with 2 times 2 times 5. We're checking, is that equal to 12? So again, this here's my x, that there's my y. And we'll do 2 times 2 minus y, which is 5. So there's my x, there's my y. Is that equal to minus 1? Is everyone seeing what we're doing? Everyone okay? Awesome. All right, then simplifying, this is going to be 2 plus 10. Is that equal to 12? Well, yes, it is. And in this way, we have 4 minus 5. Is that equal to minus 1? Well, yes, it is. So I'll just do this up here. So the answer to B is yes. 2, 5 is a solution. Is that the only one? Well, we'd have to kind of look at this a little bit more and the different, maybe just find all of the solutions. We'll do on the next page. Any questions on B? All right, then go ahead and try C while I just take a quick little breather and see what we're looking at next. So up on the screen, I have the setup. On the left-hand side, I plugged in x equal to 1 and y equal to 3. And let's see, 1 plus 6, is that equal to 12? No, it is not. So honestly, the moment one of them is not a solution, you don't really even need to do the other. So you can immediately just say no, but if you did want to check both just for practice, you can see that 2 minus 3 is equal to minus 1. That is true. So it would satisfy the second. It's a point on the second equation's graph, but not on the first one. So any questions about what we did here? All right. So now that we know how to check if something is a solution. That's a little bit tedious because it's just trial and error. If we needed all the solutions, we have 3 different methods that we can use. The graphing method, the addition, or sometimes called the elimination method. Just to kind of know what language to use for the day, how many have heard of the elimination method? Okay. How many have heard of the addition method? How many are like, I don't remember this stuff? There's a few of you, that's fine. Again, this might be familiar, and again, chapter 6 is the algebra section, and I think we've all had some algebra courses before. We're going to learn how to solve this equation by graphing. Then we'll use the addition method. I saw a few more people familiar with that language, so I'll just call it that. And then lastly, we'll use the substitution method. So what we have right here, let's go ahead and just do the graphing method first. And we have 2 lines. Each line is already set up for us. So if you look at, let's call this line 1, and we'll call this line 2. So if we look at line 1, it has a slope. Let me make my pen a little bit smaller. It has let's start with the y-intercept. It has a b of 4, and it has a slope of 1, or 1 over 1. So we have right here, we're going to go to 4. We're going to rise 1, run 1, and I'll go ahead and draw the line through those 2 points. Now, the downside with the graphing method is you have to get a fairly accurate line in both cases for it to work. So zooming in here, just to make sure this is accurate, notice that the slope here was 1. So from any point, I should always be going up 1 over 1, up 1 over 1. So again, that's just a quick way to visually check that my line is accurate. So the second line, we have a b, which is going to be 8, and a slope, which is minus 1. And again, you can view that as minus 1 over positive 1. So the second line is going to be up here at 8. We're going to rise down 1. So there's the point. And again, like I said, to be accurate, you could even see it's going to go right there. So let's go ahead and draw the line. Let me move that back into the correct spot. That looks pretty good. And the intersection, as we saw in the previous page, is going to be the solution. So I'll just simply write down here. The solution to this equation, the only one, is going to be that point, which is going to be 2. And let's see, that's 6, I think. 1, 2, 3, 4, 5, 6. So the solution is the ordered pair 2, 6. Don't look back. Does anyone remember the word we would use to describe this system? Consistent, yeah. It is indeed a consistent system. So that is the graphing method. Any questions there? Okay. The next method is the addition method. I feel like the addition method is probably the most popular one, but it really all depends on the setup that you're given. So let's look at the addition method here. Boy, I can't even spell now. Can't speak, can't spell. Boy, it's like we need a spring break or something. Let's take next week off. All right, so the addition method, what you'll do is you need to line up variables. So again, we have y equal to x plus 4. And what I need to do is make sure that I line up under that equation 2. So the y is on the left-hand side. I need to line up the equal to sign. I have to line up the x's, and I have to line up the 8's. And what you'll do is you're going to add them and try to eliminate one of your variables. This one's already set up pretty nicely for us, because if you look at, let me just highlight it. If you look at this column right here after things have lined up, those are opposites. So when I add them, they're going to cancel. So you can think that what we're going to do is we're essentially going to just add down. So this ends up being 2y, x minus x is 0, so I won't even write that, and then we would have 12. Finishing the solution here, I will divide both sides by 2, and what we end up with here is x is equal to 6. Excuse me, y is equal to 6. Do as I wrote, not as I said. You've heard me today. My words are a little bit off, but yeah, it's all right. You all got it. Future students will like it. Future you will appreciate present you. I think that's always a good way to live. Live in a way that future you will be happy with the decisions that you made with the present you. Anyway, so insightful today. Anyway, if you could even kind of look at this, notice this 6 right here is the same one we had got right there. Now, how do we find x? What you would do to find x is you'll back substitute. So you'll back substitute to find x. So what we'll do is we'll pick either equation, and let's plug y. I'm going to choose the top one right there, just because it's already it has more positive terms. So we're going to end up with a 6 plus x is equal to 6 equals to x plus 4, and subtracting 4 from both sides, you end up with 2 is equal to x, or more commonly written with the variable on the left, x is equal to 2. So you can see that you get the same solution using the addition or graphing method. All right, any questions on the addition method? All right, then one more. Let's look at the substitution method. So C. There is usually a good choice on which one to use. In this case, honestly, they're all about equally good because of the setup. The substitution method, what we'll do, and I'm going to just go ahead and rewrite the system over here just so I could zoom in a little bit. So I'm going to rewrite the system. It's going to be y is equal to x plus 4. And then we have y is equal to minus x plus 8. So just rewrote the system from above. And you're going to take a look at and see if you've already solved for one of your variables. You notice that this variable is already solved for. So what you're going to do is see what it's equal to, and you can go ahead and take whatever it's equal to, and you can just put it into the other equation. So what happens when you do that is you'll end up with an x plus 4, because I have put it into I put the first equation into the second, and then it'll be equal to a minus x plus 8. And from here, you only have one variable, so you solve it in a similar way to how we did last week. So I will just go ahead, and you have some options here. I'm going to add x to both sides. At the same time, I'm going to take away 4 from both sides. So I end up with 2x is equal to 4. Dividing both sides by the 2, I get the same x value that we did in either of the other two methods. And just like the method B, addition, we'll just back substitute to find the other variable. So what I'll do is I'll take this 2, and I'm going to just put it back into either one. I'll do that one. So we get y is equal to 2 plus 4, so y is equal to 6. So again, notice Same system. And again, if you want to write it as an ordered pair, you can. If you just want to write it like x equal to 2, y equal to 6, you can. I can't remember the format on the test, so just ask me after break on the review day, and that will we'll go ahead and kind of look at it from there. Any questions on any of these methods? Okay. On the next one, let's just go ahead and say let's use a method of our choice, and let's see kind of what other things we may run into. Now, on this one, what do you guys think? What would you choose? So let's say instead of A, B is C, just looking at this, what does it look like you would use? Graphing, addition, or substitution? Just hold up 1, 2, or 3 for A, B, or C. Okay. No one seems to like graphing. That's okay. That's a lot of work. So graphing, you would have to solve this, do some division. We don't have a graph set up for us, so I'm probably not going to do the graphing. Now, when it comes to the addition or substitution, I would actually say that they're equal in difficulty here because it's not perfectly set up for either. And I saw you guys split, so I'm going to just go ahead and choose the addition method because it illustrates a concept we haven't looked at yet. If you were to do the substitution, you would just have to go ahead and like solve this, so you would get like y is equal to like 3 minus x, and then you can go ahead and do the substitution there. But I want to do the elimination or the addition because it illustrates the concept of what to do when they're lined up and nothing would cancel. So again, I'm going to just kind of rewrite this just to make it a little bit cleaner, and don't stress about this brace right here. Sometimes this brace is used in mathematics just to kind of hold things together. So this is just, it's still a system. It's just using that brace notation on the left. Okay, so we have x plus y equals to 3 as our first equation. Then we have 2x plus 2y equal to minus 4 as our second equation. I've lined up my variables with the equal to sign. And the issue I have is if I were to add, none of these cancel. So what I'm going to do is I'm going to say, okay, I need this to be minus 2. But if I need to make that minus 2, what I'll need to do is multiply everything by minus 2. So that'll become minus 2, that'll become minus 2, and then also on the other side of the equation, that'll become minus 2. So I'm going to again rewrite the system. So now we have a minus 2x minus 2y equal to minus 6. And then we have, again, the 2x plus 2y equal to minus 4. Does everyone see what I did there? Great. Now I have the ability to just add down the columns. So let's see what happens when we do that. So I end up with, let's see, minus 2 plus 2 is 0. Minus 2 plus 2 is 0. And then minus 6 plus a minus 4 is minus 10. So I end up with 0 is equal to minus 10. Okay, that's not good. I've lost my variables. I lost my x and my y. We ran into this last week when we were solving just a single equation. Does anyone remember what the solution was, or if there was any, when we had a situation like this? Does anyone remember? No solution. We have no variables, and we have a false statement. So this is the scenario that these lines are actually parallel. There's no solution. Without looking back, does anyone remember the word we used to describe the system? It starts with in. Inconsistent. So again, this is technically an inconsistent system. Any questions on this one right here? Okay. So let's look at the next page and see what we have right here. We have 3 more examples. Let me give you, let's see, we got about 20 minutes left. This is perfect. So go ahead and start working through those. And what I'm going to do is I'm going to give you about 90 seconds to 2 minutes on each one. So if you get it and you can check your answer on the next page, move on to the next one. But if you are struggling, just think about it for those few moments, and then we'll go over them together. Kind of like 90 seconds, 2 minutes at a time. If you're good on 4, feel free to continue on to 5. But if you're struggling, here's my solution. On number 4, I would probably choose the substitution method. The reason being is I actually already have y solved for. So So again, I'm gonna use substitution here. And the reason I am choosing that, again, you could have done elimination pretty easily just by multiplying everything by 2. Actually, you wouldn't need to multiply it by -2 to get the cancellation there. You would have had to rearrange things, so it's a little annoying to do addition, but it's not too bad. But I'm going to go ahead and take this, what's already solved for y, and plug it in here. So I end up with a 2 times what I'm substituting in, the minus 2x plus 3, and that is equal to 6x just 6 minus 4x. So from here, it's very similar to what we did last week. I'll distribute the 2 to get minus 4x plus 6, and that is equal to 6 minus 4x. And then I will go ahead and add 4 to both sides. Honestly, you may actually even choose to add 6 to both, or subtract 6 from both sides, but if you notice right here, this is the scenario where we actually lose our variable, but we're left with a true statement. How many solutions are there here? Did anyone get this far? Infinitely many solutions. So again, we're left with a true statement, or it was equal. So we end up with infinitely many solutions. And because these two lines would basically be on top of each other, we would call it a dependent system. Any questions on 4? Yeah. It wouldn't be. I'll go ahead and do that method just as well, so you can maybe see where things went. Did anyone else use the addition method on this one? A couple of you. So again, if you want to do the addition, let me just go ahead and rewrite the problem. I do need to line things up, so we have y is equal to minus 2x. And then the second equation is going to be 2y, and then I need to reverse the order, so that's going to be minus 4x. So I'm going to go ahead and multiply everything here by minus 2. So that will end up giving me a minus 2y equal to positive 4x minus 6. And then you would end up with the second equation coming down. So 2y equal to minus 4x plus 6. And notice here, though, since these are lined up and you add, you get 0. Minus 2y plus 2y is 0y, or just 0. And then it is equal to 0 plus 0. So again, you get 0 equal to 0. So maybe you check where you lost. You should still lose your variables regardless of what method you use. Did you figure that out?
Yeah, but y, that's just put 0.
It happens. Question?
Also, 0 equals 0 is the same result?
Yes. The main thing to note, let me maybe just write this to make it clear. Whenever you could actually even see it here, to be honest. Whenever you have both sides of the equation equal to each other, that means they're dependent on each other. So any value of x you plug in would give you a true statement. So essentially, so there's two scenarios. If you lose your variables, just don't lose your marbles. Okay, lose your variables and a true statement. That is when we have this infinitely many solutions. Above we had the situation where you lose your variables and you're left with a false statement. This is the scenario where you would end up with no solution. Does that help? Great. Any other questions on 4? All right. So let's go ahead and look at 5 and 6. We'll go through these really quick, and then we're to our break. Exciting. All right. What method did you all do on 5? Just throw it out. Addition or substitution. No one said graphing, and everyone just stared at me like, whatever you want. Let's just get to our break. Okay. Honestly, on this one, I would probably end up choosing... I am just a little fond of addition, but substitution would also work. So the reason I would choose addition is because I'm already looking that this one's positive, this one's negative. Well, other way, this one's negative, that one's positive. Everything's already lined up for me. So all I need to do is multiply everything up top by a -2, and I end up with a minus 8x plus, oh, no, I don't want minus, I just want positive. Sorry about that. So it's already opposite signs, so I'm going to just need to multiply everything by 2. So this is 8x minus 2y equal to 4. And then the second equation is 3x plus 2y is equal to 7. I will then go ahead and add these, and then you end up with 11x plus 0 is equal to 11, so x is equal to 1. And then I will back substitute choosing either equation. So I'm going to choose the first one because there's less multiplication. So 4 times 1 minus y is equal to 2. So 4 minus y is equal to 2. I'll add y and subtract 2. So add y, subtract 2. I find that y is equal to, well, I'll just write it this way first. 2 is equal to y, or y is equal to 2. I feel like the test did have the ordered pair as your solution, so that is going to be 1, 2. Any questions on number 5? Again, to do the substitution method, all you would have had to do is solve this top one for y first, and then just plug it into the second one. The second one is probably easiest to solve for y. And number 6, what method did you all use? This one's really nice. Already set up for us. The addition, add down directly because everything's lined up. These are already opposite signs. So this is going to end up being, so adding, so that's going to be 4x. Then you'll have 0 is equal to 12. Divided by 4, x is equal to 3. And then we'll go ahead and take this 3, back substitute it, and you have 3 plus y is equal to 4. Subtract 3 from both sides, and you get y is equal to 1. And our solution would just be the point 3, 1. All right, how many were 3 for 3 on that one?